My name's Graham Hammer. I'm a professor in crop science at the University of Queensland, and I work in the area of crop physiology and modelling, where we try to understand the dynamics, an understanding of the dynamics of growth and development of plants, and capturing that in mathematical computer models so we can predict what might happen with plants when you manipulate them. So in agriculture, that's pretty important because currently in the world food system, we need to increase productivity to the extent of about 70% by about 2050 because of increases in population and consumption patterns around the world. So we're in a bind and we need to do something about it quickly. So our research is really focused on developing predictive tools that can help us to think about how to get out of that bind. One of the really important things that we're thinking about in relation to using crop models is how to manipulate plants to improve their productivity into the future, given that we've also got global warming going on and weather systems changing, higher temperature, often more frequent droughts and extreme events. So we're very interested in looking at how do we get enhanced productivity given that background. And so one of the things that we do is look at using a model to simulate over a period of time. So we take historical records of rainfall. In Australia, there's a high rainfall variability, so from year to year, you've got extreme variability of wet, dry seasons, and you can see that happening all around you. With the crop growth model, we can then input that weather variability each year to the model, and we can run simulations on the computer to give us a prediction of the amount of grain mass that ends up being yield for the crop. So we can predict for each of those seasons what the yield will be like. But then what we want to do beyond that is say, well, what if? What if we can change this opening of stomata or the conductivity, the conductance in the plant? If we can somehow modify the stomata and change how the plant uses water, and we can make it slightly more efficient in how it uses water, what does that do? And so we can input that into a crop simulation, and we've done that. And when you do that, what tends to happen is it demonstrates that we can get enhanced yield out of this plant in drier seasons, because if we restrict the stomata somewhat, it doesn't lose as much water in getting that bit of CO2, which is great in that we can enhance yield in drier seasons. The problem with that is there's a trade-off, that when you have a good season, if you've got that trait with restricted stomata, you get a loss because you can't get as much CO2 in as you would normally when you've got plenty of water. So you get this trade-off between yield advance and yield loss between good seasons and bad seasons. And so you can't win every season. But that's what these experiments are about. We're looking at different plant types here to try and understand the dynamics of their stomata and how it's controlled, so we can figure out how to manipulate it.